Hello, this is Eric, and I'm working on the Task Manager for Pewter right now. So far, I've made the user interface for the Task Manager, and I've added a service called Process Service, which manages all of the parent-child relationships and what processes exist in Pewter's UI. First, I'm going to go over the user interface for Task Manager and how I built this table, and then I'm going to go over the process service itself, how it works, and then finally I'm going to be gluing both of these together. So we're going to be having this Task Manager use, instead of the sample data that's in there right now, actually give real-time updates from the process service. This is the class for the Task Manager window that I was showing earlier. It starts off with some sample data, and this data is arranged in a tree structure. We have a root process at the top. This is actually going to be called init later on, and some example child processes. So the terminal, and then the shell. Our shell is called Phoenix, would be a child process of the terminal. I also put AI plug in here. That might not happen for real, but that's just an idea. There could be something else as a separate process. I needed that to test different parts of the visuals of it. So if I switch back to the UI here, I need to test this case where we have a vertical bar on the left, um, just to see that everything in the tree rendering is accurate. This sample data is iterated over at the bottom of this class, so I'm going to jump over there. This is just a recursive function. It's the simplest way to implement it without having to maintain a stack. We pass the sample data over here and we say the indent level is 0. For each task that we iterate over, we create a row, and then we add a task to the row that's going to be in the name column, and then we add right now this just says open. We have status, but I'm going to change status to type later on. As we iterate over each process, we're also going to create some boxes to indent the name forward and add these lines that represent the hierarchy between the processes. So in this example, we have an indent cell behind AI plugin, which has a trunk inside of it. That's what I named the vertical line. And the second indent cell that has the curved line there, which I'm calling a branch. I've made the element inspector a bit larger so we can see what the CSS is doing on this page. Each indent level has a uniform 10 unit by 10 unit box. You can see I'm multiplying it by a scale variable here, just to make it easier to try different sizes of this. And then inside of that, we have a right-aligned box with a left border that has the full height of the box and half the width. And what that gives us is a vertically centered line there. Similarly with the branch, that's just a smaller box, quarter of the size on the top right, with a left border and a bottom border, and then a border radius to give us that curved effect that we see here. The styling for the table header was difficult. I found an article that explained that you can't use position sticky for a table head or a table row, but you can use it on the table head element. So that's what I tried at first, but I ran into some interesting quirks with this. I've zoomed in very, very close because this issue is subtle, but you might see there's a border at the bottom of the headers and between these two, the two headings here. If I scroll down, the border doesn't come with the background in the TH element, despite the fact that it is both of these borders that are on the TH element and it has sticky position. This is a known quirk, and this happens in more than just one web browser. So it's really unfortunate, but we can work around this by putting a nested element inside each of the headings and putting the borders there. So that's what I wound up doing. If we look at my CSS here, I just reverted some of my changes, but I actually have a span element inside the TH, and I can turn that back on. And after reloading the page, if I can find it again, I'm just going to make Task Manager small again. we can see that the border actually stays there now. So that was really confusing quirk that I didn't expect, but fortunately it wasn't too difficult to fix. Now I'm going to talk about the process management side of it. I added a service called process service in the same service registry that I created in one of the previous two videos. And this is going to create some data structures to manage processes and their relationships with children. It also creates one process called init process, under which all of the subsequent processes will be child processes. And it's registered just like any other process, except it doesn't have this attached to parent method called, because the init process itself doesn't get a parent process. In helpers.js, we have a function called launch app, and that's where we're going to create the processes for the apps. Launch app already initializes the window, and then UI window initializes an iframe. This is a really great place to create a process that we can register with process service, because this options object gives us a UUID for the process and also the UUID of its parent, which is called parent instance ID. And we need both pieces of information to create the process, which process service will be able to associate in that process tree that I was showing earlier. And we do that over here. For Explorer, we create an instance of pseudo process, and for all other apps, we create an instance of portal process. The naming convention here is just to identify that Explorer doesn't have an iframe associated with it, whereas the other apps do. So they're going to be distinguished when you see them in the task manager. Process service itself maintains three data structures: a list of processes, a map of UUIDs to process objects, and a map of UUIDs to lists of process objects, which will be the child processes of each of those processes. Registering a process is relatively simple. We call this register function here, which just adds the process to all of these data structures. And then we call attach to parent, and that's going to attach this process to the list of child processes that's associated with that parent process. And separating these two is convenient for two reasons. The first is the init process will be registered, but it won't be attached to the parent. And then attached to parent is also called in unregister. When we unregister a process, it may have child processes that haven't been closed yet. And if we do end up with these lingering child processes called orphan processes, just like in Unix, then we need to transfer them somewhere. So what we do the same thing that Unix does. We transfer the orphan processes to the init process. Hopefully, this won't actually happen very often. For example, if you closed the terminal and Phoenix Shell was still running, that is a bug. We want that background process to go away. But if that's not how things work out, we at least are able to manage that and know that the process still exists instead of just losing our connection to it and losing visibility of it in the task manager. Now we're at the live coding segment of this video, where I'm going to tie the functionality of process service into the UI for the task manager, and we're going to actually start to see the real processes on here. The first thing I'm going to do is get rid of sample data, and now we're going to iterate over everything in process service. So let's do that. First we have sample data here, and we're going to replace that with child processes from here. We want the processes of the init service. So I might just make a method here, get children of UUID, and that's exactly what I want that to do. I also need to expose this null UUID because I'm going to want to be able to get the init process. Or I could do this. If not UUID, UUID equals null UUID. I'll do that. It works just as well. And then over here, I'm going to call that. And I'm just going to pass nothing to get children of, to get the processes of the root. Now I need to change iter tasks. Iter tasks needs to get a different list over here than what it's getting right now. So we can probably just call process service get children of item.uuid. I think that will work. The other thing that's different is these item objects. They're no longer what they were before. They're no longer objects from my sample data, uh, which I removed up here. They had a name attribute. These I don't think have a name attribute yet, so I need to add that back. That will happen in somewhere in definitions.js. That's where I made this process class. And I think I'm going to make name one of these top level properties. I'll put it after UUID and parent. So that will exist for all processes now, and I need to make sure it's also in helpers in the launch app function. For both of these cases, one is Explorer. I seem to be missing that code here. I see what happened. It was in my stash. So for Explorer, we add the name Explorer. And down here for portal process, we're going to add a name based on the name of the app. That's just going to be app.info.name. Now we have the name available, so we can proceed to do this as I'm doing it here. This needs to be replaced with that. And in theory, that should be it. Code never works on the first try, so we're going to give this a spin and see what actually happens. I didn't reload this UI yet, I think. So we have a blank window, which is a starting point. We don't have a console error, so I'm going to investigate this for a moment, and then I'm going to come back with another video clip. It turns out the reason that I wasn't seeing anything in the task manager is because I didn't have anything open. But there is another issue. If the terminal's open, I actually have a couple processes open. I have the terminal and our shell called Phoenix. If I go into the process service, so that's global this.services get process, and I look through UUID to tree list, I should see that the init process has a portal process in it, which is going to have this UUID starting with 933. If I open that one, I see a portal process with UUID 638, etc., called Phoenix, and that's down here. So the data structure is accurate, which means there's still an error in how I'm iterating over the processes and rendering them in the task manager here. It turns out the cause of this error was also something really simple. I forgot to change this reference to item.children to just children from what we got from getChildrenOf in the process service. So now when I reload this page, that's actually going to cause a problem. Hang on. I'm going to reload without that app name at the end. If I open the terminal and open the task manager and get rid of this breakpoint, there we go. I see terminal and Phoenix. I don't see the init process in the list for some reason, so that's going to be the next thing I investigate. The reason it wasn't displaying the init process, it turns out, is just because I didn't tell it to. There's a list of processes here, and I'm getting it from the init process. What I really would have wanted to do was get the init process and then put that in an array here. So const processes will be an array, and then there'll be one item. That item will be the init process, so I'm going to say get init, and yeah, that looks right. Service process get init, We can probably just put this on one line. I think doing that was a little extra, and there we go. So now when I reload the page and open a terminal, that says undefined right now. I guess because I didn't define the name on the init process, which is going to be easy to fix. And that almost looks like it's working, but we have a visual quirk here. So that's going to be the next wonderful bug that I get to fix. And the init process will be named pewter. I think I may have fixed that. That was a complicated one. The reason that we were having this issue is because, let me expand that. This was only checking if we weren't the last cell. If we weren't the last cell, we'd always put the trunk, but we actually need to know if that cell, with respect to the corresponding ancestor, is the last item in the list. In my sample data above, if I go and expand that, I did not end up testing this case because, as you can see, I had an item at the end of the parent list, which Terminal and Phoenix Shell were in. So I wasn't testing that case of the last child in a list is a subchild. The solution involved tracking a list of last item flags. So each time itertask is called, I extracted last item out of this object here, and I append it to this list, and I'm appending it in a clone so that it doesn't affect the, so that we can, yeah. Now, to really test this, I should open another window and make sure that we do get the trunks again. I need to close the task manager and reopen it for now. And it looks like I did in fact break that, so that's fun. It turns out the solution to that little dilemma was to add a +1 to this index here. The reason for that is because the init process, we don't draw a bar to the left of that. So we're kind of technically starting at index 1 in theory. Now we can see that both are working fine. So if I open a terminal and then task manager, we don't have the vertical bar here, but if I open Explorer and then open task manager, we do have that vertical bar here. So everything seems to be working as we want. The next thing to add to this is real-time updates, which aren't happening right now. And that I'm going to do in a part 2. So that will be in another video. Hello, it's Eric on another day, and I just realized I forgot to do an outro for the Task Manager video. So this is the outro for the Task Manager video. I stated earlier that I would do the refresh for the process list in a part 2, but that actually, as it turns out, was really simple. It was just a set interval and clear interval when the window closes. However, it is redrawing all the process rows right now, so there's some more work to do there and giving each row an ID so we don't have to redraw all of them. I think the next video on Task Manager will just be about improvements to the Task Manager app in general. As always, thanks for watching this video, and hopefully I upload some more cool pewter videos soon.